Okay, problem number 13, the infamous hanging hippo problem. A 3,500-pound weight is suspended by two cables as shown in the diagram. Find the tension in each cable, T1 and T2. 3,500 pounds is a weight, but it is also a force in physics. Pounds is a unit of force, and so we can use that value to find the tension in pounds in each of these cables. And so let's draw ourselves a free body diagram. We know that all the forces are balanced because this thing is not moving side to side and it's not moving up or down. And so we can draw this diagram. Let's draw first. Let's draw. Ooh, that's a very unstraight line. Let's go straight down and let's let that represent this 3,500-pound force going down. And then what do we know? We know these two different angles right here. We've got a 40-degree angle going off to the left, and so I'm going to draw this going off like that, and then I've got another line going up. I can't work this. Going up like that. And now I want to sketch in the different components of this. So I've got there that horizontal component and that vertical component. And this was my 40-degree angle. And let's do the same thing here on this other one. I've got that horizontal component, and I've got that vertical component right there going to that pink vector with my 55-degree angle right there. Now, to the best of my ability, I tried to show that those horizontal components were the same length because they need to be. Remember, these vectors are representing the both direction and force tensions in these cables. And since the horizontal forces, since the weight isn't moving side to side, the horizontal forces need to be balanced, meaning those two components need to be equal in length. Similarly, since the weight is not moving up or down, the two vertical components of those triangles up there need to equal the entire vertical component of this 3,500 pounds since it's not moving up or down. So I should probably make that a little bit longer to make this diagram a little more accurate looking, a little more to scale. So what do we know from these two equations? Let's draw it as little like vector diagrammy first because that'll be kind of fun. So we know that this thingy has to equal this thingy because they are not moving at all. And we know that this thingy plus this thingy has to equal this thingy because all the forces are balanced. But let's make this a little more specific. Let's label the different components here. First off, we've got T2 as that cable, tension in that cable, and we've got T1 as a tension in that cable. So let's go ahead and write the vertical and horizontal components of this using trig. We know that the vertical component will just be the tension, the hypotenuse, the tension, times the sine of the angle. So on the right side, we're going to get T2 times the sine of 55. And on the left side, we're going to get T1 times the sine of 40. And now similarly for the horizontal components, we're going to get the same thing except times the cosine of that angle. And again, this is just right triangle trig that we're doing right here in a pretty good, straightforward application of it. So now that we know all those pieces, we can write these equations a little more formally as T1 cosine of 40 equals T2 cosine of 55. And that is one equation. The next equation that we get is going to be T1 sine of 40 plus T2 sine of 55. That was supposed to be green. Boop doobie 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 doop boop boop. Plus T2 sine of 55 equals that 3,500 pound force going straight down because all my forces are balanced. So I'm going to enter this as a matrix. It is the absolute easiest way to solve this problem, I think. So I'm going to have a T1 column, I'm going to have a T2 column, and I'm going to have what those are equal to. So first one, T1, my first coefficient on T1 is the cosine of 40. And then what's the T2 in that top equation? Well, I need to subtract T2 cos 55 to get it on the same side. So I'm going to get negative cosine of 55. What is that equal to? Well, that will be equal to 0 by moving that over. In the bottom, I've got T1 times sine of 40. And then I've got T2 times the sine of 55. And that is all equal to 3,500. So run this through your calculator, and you should get your answers very quickly and find that T1 equals blank and T2 equals other blank. Fill it in. If you're careful and make sure you're in degree mode, you should find that the tension in cable 1 is 2015.19, I should say, pounds, and in T2 it is 2,691.4 pounds. My calculator was automatically rounding that poopily for me for some reason. 2015.18. Oh, I changed colors. That's okay. 6, and then 2691 point. That instead of 4, let's make that a 397. Keeping consistent, going to 3 decimal places like that. Yay.